How's things in the world of the discovery of the universe?
Exciting.
Yes,
I
very.
would say. I've been doing some work on black holes recently, which I hadn't started last time I saw you, actually. So I got interested in it. And the amount of the progress that's been made in trying to understand how they work, and a question that was posed by Stephen Hawking a long time ago, really 1970s, early 1980s, which is what happens to stuff that falls in. But the simplest question you could possibly ask.
Right.
There's progress being made on that now, which I think is profound and exciting.
How is the progress being made? Like how do we study a black hole?
I mean, it's mainly theoretical, although we have now got photographs of them. So we have two photographs, which are radio telescope photographs.
Right.
One of the one in the center of our galaxy, which is a little one. It's called Sagittarius A star. It's a little supermassive black hole. So it's about 6 million times the mass of the sun, which makes it a little supermassive one. And then there's another one, the first photo that was taken. It's a collaboration called Event Horizon. And they took a photo of one in the galaxy M87, 55 million light years away. That thing is around 6 billion times the mass of the sun. I mean, imagine that, 6,000 million times more massive than our sun.
Is that the largest black hole we've ever discovered?
No, there are bigger ones than that, but that's that's the scale of them. It's a big-ish one, that. But if you think about it, I mean, so there's a number. It's called the Schwarzschild radius of the thing. So if you took our sun, which you can fit 1 million Earths inside, and collapsed it down to make a black hole, it would form a black hole when it shrunk within a radius of 3 kilometers, about 2 miles. So you've got to take this thing, which is what I have to convert from kilometers to miles, don't I? But it's about
that's okay. Just say kilometers.
700,000 kilometers. So it's about 500,000 miles radius or something like that. The sun. So you squash it down till it's about 2 miles, and then that would form a black hole.
Wow.
The 6 billion times the mass of the sun means you multiply that by 6 billion. So these things, the so-called Schwarzschild radius is, I don't know, larger than our solar system. Basically,
oh
this
my
thing
God,
that sits in a galaxy. So we've got these two photographs.
Larger than our solar system.
Yeah, the event. Right. So it's a big structure.
Oh,
that's a Chandra X-ray image of. There it is. That's it. So the that one there. That's the M87 black hole. So what you're seeing there is the emission from the material that's swirling around it. It's called the accretion disk. So you have material that's orbiting very fast, emitting a lot of radiation, and that's what you see. It's a flat disk, by the way. So you think Saturn's rings. So this material is very flat. But what you're seeing in that photograph is the light rays being bent around the black hole from that flat disk. So that was a prediction from Einstein's theory, basically. He published it in 1915. And you can predict that that's what one should look like. And then just about, what was that, 4 years ago now, maybe 5 years ago, for the first time in history, we get an image of one, and it looks like the prediction. So It's a remarkable thing.
How phenomenal is that?
Yeah. So we've got